Welcome dear learners. This is third video session of chapter matrices of class 12 mathematics. For this video session, we will have following learning objectives. After going through this video, you will be able to multiply two or more matrices. You will be able to apply multiplication of matrices to solve problems. Let's recall. A matrix is a rectangular array of numbers or functions. The numbers or functions are called elements of the matrix. Matrix is denoted by capital letter and its elements are denoted by small letters. A matrix having m rows and n columns is called a matrix of order m by n. Two matrices A and B having same order can be added by adding their corresponding elements. Similarly, two matrices A and B having same order can be subtracted by subtracting their corresponding elements. If A is any matrix of order m by n and K is a scalar quantity, then Ka, the matrix Ka is obtained by multiplying each element of A by K. Why do we require to multiply matrices? That is next and the last operation on matrices. You have done addition, subtraction and scalar multiplication. And now the fourth and the final operation is multiplication of matrices. But why do we require it? For example, Aryan wants to buy 2 files and 3 registers and Sia wants to buy 4 files and 7 registers. The price of one file is 10 rupees and register is 30 rupees. So how much money do they need to spend individually? So Arya needs 2 files into rupees 10, that is 20, plus 3 registers into 30 rupees is the cost of one register, so 3 into 30, and total he requires 110 rupees to buy. Sia needs 4 into 10 plus 7 into 30, that is rupees 250 to buy all the stuff that she wants. So how can this information be represented by using matrices? Let's make one matrices of requirement 2, 3, 2 files and 3 registers, 4, 7, 4 files and 7 registers. Then price 30 rupees and 10 rupees has also been written sequentially. Money needed, how much they require. So this calculation has been written here for Aryan and for the second element it has been written for Sia. When you solve this, you will get this as the product of two matrices. So it arranges the given data and calculations become a bit more better when we use matrices for all such calculations. Let us consider the two matrices 2, 3, 4, 7, 10, 30. They are being multiplied in this manner. So have you observed anything? It can be observed that to multiply any two matrices, we must have number of columns of the first matrix. They must be equal to the number of rows of the second matrix. That means this matrix number of columns and this matrix number of rows. It has got 2 columns, it has got 2 rows. So they have to be equal. Elements of the product matrix can be obtained by multiplying elements of rows of first matrix and columns of the second matrix and then adding them up. Two matrices A and B are multiplied to obtain a matrix C if Aij is of order m by n and Bjk of order n by s. Do take care that this n and this n have to be equal. Then we obtain a product of matrix which is of the order m by s. You can see that this n has been cancelled and the product matrix will have order m by s like this. So let us do few questions. Check if the following matrix products are possible or not. How will we check it? For the first case, let's take matrix A, its order is 2 by 2. Matrix B, its order is 2 by 2. So you can see that this 2 and this 2 are same, they are equal. So this matrix product is possible. For the second case, I'm given matrix A as 1, 2. Its order is 1 row, 2 columns, so 1 by 2. In the second case, I'm having order as 2 by 1. So again, this 2 and this 2 are equal. So this matrix product is also possible. For the third case, check out the order. This is 2 by 3 and this is 2 by 2. So you can see that this 3 and this 2 are not equal. So this matrix product is not at all possible. For the last and final example, we are having order of matrix A as 3 by 2 and this is 1 by 3. Again you can check that this 2 and this 1 are unequal and this product of matrices is also not possible. For any three matrices A, B and C, let us study properties of multiplication of matrices. So matrix multiplication is associative. That means AB when multiplied with C and A multiplied with BC, both are going to give me same answer, provided this product is possible on both the sides. Then comes distributive law, which is A multiplied by B plus C is giving me AB plus AC. The second version is A plus B multiplied with C is giving me AC plus BC. Third is multiplicative identity. For every square matrix, mind the term square matrix A, there exists an identity matrix I of the same order such that AI is equal to IA is equal to A. If that condition is satisfied, we say the multiplicative identity is this matrix I. Commutative law. You can say that AB and BA, this product is not equal in majority of the cases. When they becomes equal, they becomes inverse of each other. That we'll do later in this chapter. Now let us solve NCERT exercise question 1 part 2. These are the two matrices given to you for multiplication. Let us first check their orders. This has 3 rows and 1 column and this second matrix has 1 row and 3 columns. So this one and this one are same and the resultant product of matrix will have 3 by 3 order. So how will you do that? 1 multiplied by 2, 1 multiplied by 3, 1 multiplied by 4, 2 multiplied by 2, 2 multiplied by 3, 2 multiplied by 4, 3 multiplied by 2, 3 multiplied by 3 and 3 multiplied by 4. So that becomes product of these two matrices A and B. Let's do one more question. Now this time order of first matrix is 3 by 2. Order of second matrix is 2 by 3. So again you can see that we will be getting 3 by 3 order matrix. So how will you do it? First row and first column are to be considered for the first element. 2 into 1. Plus 1 into minus 1. That becomes the first element A11. Then comes the element A12, first row and second column. First row and second column and products are to be added up. The third element A13 is first row and third column. Right? Similarly, you can complete other two rows by taking second row and first column, second row and second column, second row and final third column. And for the last row, minus 1 into 0 plus 1 into 2. Then last element is minus 1 into 1 plus 1 into 1. This is how you are supposed to calculate product, and of course answer is to be given by carry out all this calculation work. 2 minus 1, 3 minus 2, minus 1 minus 1, 0 plus 2, 0 plus 4, 0 plus 2, last is 2 plus 1, 3 plus 2, then minus 1 plus 1, that is giving us 0. So that becomes product of these two matrices. So let's do one more question. Question number 17 of exercise 3.2 of NCERT. You are given a matrix A of 2 by 2 order, matrix I of second order, and you are supposed to find the value of K such that A square is equal to Ka minus 2i. This matrix equation is satisfied. So A square is to be calculated. Matrix square, as you calculate 2 square, like 2 into 2, then the same manner you have to calculate this matrix square as A into A. So write A adjacent to itself, 3 minus 2, 4 minus 2, that is to be multiplied by this. So I'll get 2 by 2 order matrix. So 3 into 3 minus 2 into 4. So this becomes and the next will become and then 4 into 3 minus 2 into 4, and the last element will be 4 into minus 2 minus 2 into minus 2. So this after calculation will give us a matrix 9 minus 8 minus 6 plus 4, 12 minus 8 minus 8 plus 4. So that becomes matrix A square. Now let us write this given matrix equation. A square is equal to K into A minus 2i. So substitute all the values, 1 minus 2, 4 minus 4, write down this K as it is, A 3 minus 2, 4 minus 2 minus 2 times identity matrix, solve it, write it as it is, then this 2 is to be multiplied and this can be solved further. I'll retain Ka on one side and shift 2 times identity like this, and this is K into 3 minus 2, 4 minus 2. So let us simplify this matrix equation now. 1 plus 2, 3 minus 2 plus 0, minus 2, 4 plus 0, 4, minus 4 plus 2 is minus 2. This is equal to K times matrix A. Now, in place of going further with the calculation work, just compare on both the sides. Isn't this matrix and this matrix are equal? So you can conclude here is that K is equal to 1, and that becomes your answer. So let us summarize whatever we have studied in this video session. Two matrices A and B are multiplied to obtain a third matrix C if A has order m by n and B has order n by n. Remember, this n are to be equal. Then you obtain a product matrix M of order, product matrix C of order m by s. Number of columns of first matrix to be equal to the number of rows of the second matrix. Matrix multiplication is associative in nature. AB multiplied by C is equal to A multiplied by BC whenever product of matrices is defined. Distributive law is also applicable on this. A into B plus C is equal to AB plus AC. A plus B into C is equal to AC plus BC. Multiplicative identity. For every square matrix A, there exists an identity matrix I of the same order such that AI is equal to IA is equal to A. Commutative law, that is AB is equal to BA, doesn't hold for matrices. In general, AB is not equal to BA. That's all for this video session, students. In the next video session, we will study more about matrices. Thank you, everyone.